So this video is the first one about solutions from Unit 13. And it's a little bit of an introduction to solutions and solvation and what that means when we draw pictures and what is an electrolyte solution. So solvation of ionic compounds in water, we've talked a little bit about this before when we talked about solubility rules. So what happens when you take an ionic compound, like in this case this is sodium chloride, and you drop it into water and it dissolves? So what's really happening there? So when it dissolves, each ion, each cation and each anion kind of breaks off from the lattice structure. So this is the lattice structure that it makes when it's a solid. Each ion comes apart and is separately surrounded by water molecules. So one thing I want you to note is that it's not random how we draw the waters here. So the chloride, the Cl minus, is surrounded by waters, but it's surrounded by the hydrogen end of the water. Remember that water is a polar molecule. It has a plus side and a minus side. The plus side is the hydrogen side, and the chloride, because it has a minus, is surrounded by the hydrogen end of the water. And the sodium, because the sodium is a cation, it has a positive charge, it is surrounded by the oxygen end of the water. And these are a little bit simplified. This is actually a sphere. It's a three-dimensional. It's surrounding it in all directions. We don't draw that because it's just too hard to draw, but just keep that in mind. Okay, so most ionic compounds dissolve in water for the reasons that we just talked about. But some, because they're really attracted to water. But some ionic compounds do not dissolve in water, and why? So one of the compounds that doesn't dissolve is silver chloride, and it's insoluble in water because what happens is for some compounds the force of attraction between the ions is stronger than their attraction to water. So silver and chloride make a stronger bond than the attraction that silver has for water and chloride has for water if we add all of those energetics up. How do we know if something's going to dissolve in water? We use solubility rules. So here's an example of a problem. If I had 5 moles of calcium bromide and I dissolved it in 1 liter of water, how many moles of each ion would I have in solution? So 5 moles of calcium bromide, dissolve it in water. For every calcium bromide, I'm going to have 1 calcium and 2 bromides, and that means I'm going to make 5 moles of calcium in solution, which I didn't write down here, but this should be 5 moles, and then 10 moles of bromide is going to be in solution because I have 2 bromides for every. So we would call this the concentration of the ions, or the ion concentration. And just a note here, we use AQ, which we've seen. AQ means dissolved in water, but it specifically here means that each ion is surrounded by water. So when we write ions here and say bromide with an AQ, we do this instead of drawing the water molecules like we did before. We don't really want to be drawing all the water molecules every single time. So AQ means surrounded by water. So ionic compounds dissolving in water is related to electrolytes, which we've mentioned earlier in the year, but it's good to just make sure that's really clear here. When we talk about an electrolyte solution, we mean a solution that has ions that are dissolved in water. So sodium chloride, if you had sodium chloride solid and you added it to water, it would make an aqueous solution, and we will call this an electrolyte solution. So electrolyte solutions means that it can conduct electricity, and in order for this to happen, it has to have ions dissolved in solution. So here's a picture. If we had a meter that would measure the conductivity of the solution and show it with a light, the solution of sodium chloride in water, the light would turn on and we would say, yes, that's an electrolyte solution. If I have plain water, that's not going to conduct electricity. And if I have solid sodium chloride here, because it's not dissolved in water, it's not going to conduct electricity, even though it's an ion, but it's not an ion dissolved in water.